number 2. So it says mark yes or no if the values can be substituted for the variable to make the equation true. So for these problems, what we're going to be doing is substituting in variables. And this kind of goes back to like what I was saying in previous lessons. Whenever you have a variable and you know what it is, all you have to do is plug it in. So it says a is equal to 3, so you just have to plug in a to the equation. So let's see. Let's plug in the first one. And is this something that you guys have done before or not really? Not really? Okay, I'm getting like half and half, so I'll try to re-explain this. Or explain it for the first time.
I've done it before.
Let's see. It says you're going to be plugging in 3 into 5a minus 1 is equal to 14. So what do? You plug in the 3. And this is why I said I like to put parentheses, because when you put parentheses, remember that it's another way of writing the x for multiplication. But since we do that so much in algebra, that's why I like to put it, just because it's so common in algebra. So we're plugging it in whenever we see an a. I'll rewrite this again just so it's easier to point out. We're doing 5a minus 1 is equal to 14. And we're plugging in 3 whenever we see a. So I'm going to plug it in right here. And remember, you multiply these two numbers, because when you plug something in and you see parentheses, that's another way of writing the x of multiplication, like I said. So you're going to be multiplying 5 times 3, and then you do minus 1 at the end. So then 5 times 3 is 15, and then you do subtract minus 1, and that's equal to 14, and then 15 minus 1 is 14, which means that this is true. 14 is equal to 14, which means that when you plug in 3, you get the right answer. You get 14. So that would be yes.
Right. If you haven't, if you like forgot to put the parentheses, you would get confused and think it's 53. So that's why the parentheses are important.
Exactly. I agree. So it's just at least a tip for you guys. You're gonna find that the parentheses are the easiest way to just show multiplication. I was the same way. I like to write the x. I like to write even the dot sometimes. But when you get to algebra, it's just so much easier to write the parentheses. And if you remember that it's multiplication, it just makes your life that much easier. Someone in the problem.
This looks like an ancient language.
Someone in the chat box said they didn't understand the problem. So I'll just kind of like redo it. So I'll clear this for now. But basically,
I just got it. Like I just got it.
Okay, perfect. So basically, just so that because I know I didn't like kind of explain the problem first. Basically, what we're doing is we're marking yes or no, and we're seeing if each value that it's giving. So a is equal to 3, b is equal to 10, f is equal to 2. We're just plugging it into the equation to see if it's true. And if it's true, we put yes. If it's not true, we put no. So that's basically what we're doing. That would be yes, because it worked out. But let's look at number 2.
All of them are yes.
All of them are yes. Let's look at let's look at the second one. So it says 100 minus b squared is equal to 80. So of course you guys know that we have to plug in 10, because b is equal to 10 whenever we see a b. So 100 minus 10 squared. See how we plug it in only when we see the letter? That's the correct way to do it. Because if you write 100 minus 10 squared, yeah, it kind of looks kind of confusing. I mean, it kind of looks right, but then you might think it's negative 10 squared. It's not negative 10 squared. It's minus 10 squared. And those are two different things. Because when you do this, you end up getting 100 minus 100. When you do this, you get 100 plus 100. Because minus 100 squared is, minus 10 squared, I wrote an extra 0, is 100. It's positive 100. And once you've gotten rid of the negative, you can't bring it back. So that really, and even when you're just writing answers on a test, your teacher might mark you down for writing it this way, the way that it's not supposed to be written. That's why I always recommend to use the parentheses. It's just the easiest way to see things. And it kind of saves your answer whenever you do something wrong. So let me erase this wrong version of doing it and go back to the right way. So, like I said, you just need to know that you're squaring 10. So I think someone said that it was yes, but I think what you did by accident was you did 2 times 10, and then got 20, and did 100 minus 20, which is 80. But squaring is not the same thing as multiplying. Squaring is multiplying that number by itself. So that's like a really that's a very common mistake. A lot of people do it. Even I do that sometimes. But really with this one, even if you're unsure what 10 squared is on just off the top of your head, you know you can just always do 10 times 10 on the side, because that's what you're doing. You're multiplying the number by itself only 2 times because it's 10 squared. So when you do that, you end up getting, that's a 0, that's 1, you get 100, like I said. So when you do this, 100 minus 100, you get 0 is equal to 80, but that's not true. 0 is not equal to 80. So this equation isn't true because there's no way that 0 is equal to 80. And when you plug in 10, you really just get rid of everything in the 100. You're not left with 80. So just make sure, at least when you're plugging it in, and don't worry guys, you're going to see a lot more of this when you get to Miss Borges, and she teaches you more math. But when you plug things in, just remember to not plug it in like the incorrect way, and also remember to do the right math. So it's going to take a lot of practice, trust me, but you guys are going to get it. So does everyone kind of understand this problem, the second one?
Yes.
Yes? Okay.
Kind of.
Kind of? Okay.
Yeah.
So at least if it's kind of and yes, you're really good. If you don't understand it, let me know just so that you can be a kind of or a yes too. So let's look at,
So basically, for like the first one, since is it because of the number? Because the letter's outside and it's the little one?
what do you mean
Does
by
it
that?
depend? Because in the first one it says 5 and it's a big 5, like a normal number, and then the A is really little. But then in the other equation, it says B as the big one and then 2 as the little one at the top.
As the exponent.
Oh yeah, 2 is the exponent, so that's why you solve it differently.
It would just be the number that B is substituting times B.
Yeah, but she's saying that in the first problem it's the A that's like in minor case or like really small, and then B is like a normal one.
Yeah.
Does that matter?
So I kind of
Not sure.
I'm not sure what what you're asking, but I think I kind of understood it. What I understood, like why I interpreted, it doesn't have to do with it does have to do with the size of the variable you're plugging in. So A is equal to 3, B is equal to 10. So if you were to plug in a different number for each of those, this one could end up being no, and this one could end up being right. It all depends on what you plug in. All we have to do is just check it into the equation and see if it works, and that's how we know if it works or not. But the other way I interpreted your question was the 5a in front of it and the b squared. The 5a, since the 5 is in front of it, you're just doing 5 times the number that's there, which is 5 times a. B squared, and remember we're subtracting it, so I'm just gonna put that to the side for now. The b squared, it's really just another way, like someone else said it, it's really just doing b times b, because that's how you get b squared. You're multiplying it by itself. If it was b cubed, it would be b times b times b. So that's what you need to remember. So really, let me just undo it, because it's not b cubed, it's b squared. You're really just doing 10 times 10, which is 100. So that's where that comes from. Does that kind of make sense, everyone?
Yeah.
Yeah.
Okay. All right. So I'm going to clear this.
It's related to the other lessons.
Yeah. So it really, that one was kind of hard just because you won't see a lot of squared the squared letters until you get to like algebra 1, I would say. Like you're gonna see them, but it's not gonna be as important. So don't worry too much if it's that one's confusing you a lot. But the right like number for this one, for number 2, I would say this one and this one are really important. So let's look at number 2.
Square? The square thingy again?
The square thing, wait, did you ask what it is or?
Yeah, what is it? Because I didn't get that
Okay,
part.
so when you have it squared, you're just multiplying it by itself. So it's b times b. Just like if you have 1 squared or 2 squared, you remember that it does 1 times 1. This one, you do 2 times 2. If you have a letter squared, it's the same exact principle. You're just doing b times b because you have it. It tells you that it's squared, which means that you're multiplying it twice
So a
by
square
itself.
is basically an exponent?
Yes, that's what it is. It's just another way of saying
okay.
the exponent. Sorry, I don't know if that was confusing. I call it squared, just because it's really the same thing. Squared means to the 2. That's a math like rule. That's how teachers will say it, or some teachers will say it. But squared basically means to the 2 in the exponent. Sorry about that. I didn't realize that was what was confusing you guys. All right, so let's see number 3 or part C, just because that's not a number 3. It's like the third part of number 2. So let's see. All we have to do is plug it in again and then see if it works. So it's really the same thing, except now there's no exponent, so it might be a little easier. So we're plugging in 2 because f is equal to 2 whenever we see an f. I see one right here. I'm going to plug it in. 32. 16 times 2 is 32. So that works. So that means that one is true too. That one I think was the easiest one just because it required the least steps.
Yeah.
Hopefully that one did make sense too.
I think I know number 3. I think I know what it is.
Okay, so hold your answer and then see if you get it. Tell me if you get it right, okay? So
Okay.
let's see. From the set of 1, 3, and 6, this kind of, it's using the same word as we did over here. The set, except that this set was 2, 4, 6, 8, ... It goes on forever. This one is just 1, 3, and 6. So it's much smaller and much easier to work with. So which of the values can be substituted for x to make the equation true? Well, for this one, what I'm going to do is I'm going to plug in each single value and see which one gives me 15. And if none of them give me 15, then the answer is none of these. So let's see. 27, I'll plug in 1 first. Actually, let me not write equal to yet. 27 minus 2 is 25, which means that when you plug in
25
1,
times 1.
when you plug in 1, you cannot get 25. I mean, you cannot get 15, which is what we're looking for. So it cannot be B because I plugged in 1, I got 25. It doesn't work. So let's try another one. All right, let's plug in 3. Let's see what we get. And again, this can be done in your head if you really wanted to. And I know that a lot of you can probably do it, but I'm just doing it just so you guys understand the best way to do it and to always check your work. That's really important. Even now, I always check my work just to be sure before I submit any test. But if I don't have time, then I'll just submit the test. But if I do, it's always good to check your work just because you want to make sure you're getting all of them right. So let's just plug in the next one. So I'm going to plug in a 3. And then 27 minus 6, 21. So that one doesn't work either. Now the only answer we have left is 6. So if it's C, like you guys are saying, it has to give us 15. So let's try it. All right.
William, come on.
So 27 minus 2 times 6. 27 minus 12. What is 27 minus 12? 15. And it gives us 15.
Can I get how I got my answer? Because I got it right.
Yes. And you got it right? Okay, perfect. So yes, the answer is C, like what you guys were saying. So really good job.
Can I say how I got it?
Sure.
I did it in my brain because what I did was like look at the 2 and then I subtracted 2 minus 27, which gives me 25. which I know that I have to keep the 2. And then since now it's 25 minus 10 gives me the 15. So then 10 plus 2 is 12. And then what number times the 2 that we have there, what number gives you 12? So I got 6.
Okay.
That's how I know it's 6. I don't
Where did
understand
you
it.
got the 10 from?
Yeah, I don't know where you got the 10
Because
from,
when you
but I think
subtract the 2 from the 27, it gives you 25. And then since it's 15, 25 minus 10 gives you 15. So then you just add the 10 and the 2, which gives you 12. And then what times what gives you 12, which is 6 times 2.
I don't know. I think okay. What I don't know. Like I don't know if that's actually like a right way to do it. It sounds weird because like you got the right answer, but you got the right answer.
I just got
But
it.
yeah, I mean it's I don't know what to say. I would say like try plugging it in your head. Like if anything, because I liked how you did it in your head. But I don't know if that way of subtracting the 2 was like math approved, just because whenever you have a letter here, and this is going to be true for most similar things, whenever you have a regular number and you have a letter for another thing, you can't subtract them just because they're 2 different things. So like if you have 27 minus 2x plus 3y minus 4z, a lot of letters, you can't do anything to that just because they all have different letters and they all have different things. If they didn't have letters, then you could do it. Or if they were all the same letter, then you could do it. But you can't. So I don't know if it's good to subtract the 2, even though it got you the right answer. I would say just plug it in and plug it into your head if that's what you prefer to do. Because I know that writing down all that work may be too annoying. But if you like to do that, of course, you can feel free to do it. But if you'd rather just do it in your head, just make sure that you're plugging in each number that was here and subtracting it from 27. And make sure you're plugging it into the 2x. But yeah, I'm not sure if that's the right. You may want to ask your teacher. You have this problem, of course, and you wrote down how you did it. You may want to ask her when you get to school, which is going to be kind of soon. Just because I don't know if that's right, but it could be right just because you got the right answer. So I don't want to like completely doubt you, okay? But I'm really happy you got the answer. All right. So does everyone understand this problem?
No.
Yes.
How do we not like, how do we remember or wait, look, when I was trying to do it in my head, I was thinking 25 minus 2, and I didn't realize that I had to do the x first before doing the.
Okay, so this is what I will
Is that
say.
the Pemdas thing?
Yes, it's Pemdas.
Right.
Oh, sorry about that. Let me write it out. Pemdas. And this is why it's okay to do it in your head, but at least you guys are literally going to 6th grade. So and it's already amazing enough that you guys are doing algebra so early. So it's okay for you to write it on your paper. I really recommend you doing that because doing it in your head, I promise that after you do so many, writing it on your paper, doing it in your head will be very easy. But for now, unless you really understand it, like really, really understand it, and if you've been doing it for a while, I definitely recommend doing it on paper because sometimes it's hard to remember PEMDAS when you're thinking about it in your head. And at least if you have it on paper, you can see, okay, I'm looking at this right now. Okay, I have to do it's parentheses, exponent, multiplication, division, addition, subtraction. And these multiplication and division, addition and subtraction, it depends on which one comes first. So really the first thing that's there is you can see it as parentheses or you can see it as multiplication. It doesn't matter. This is the first thing that should pop out to you. Either a 6 in the parentheses or 2 times 6. So we do 2 times 6, we get 12. And then the next thing we have is subtraction. So 27 minus 12 is 15. So
Sorry. I'm sorry
you
for
would have to.
interrupting. I have to go.
okay, bye. Thank you for coming. Don't worry.
I don't get how you got 2 and the 4 in the parentheses.
Wait, can you say that again?
I don't get how you got like 2 times 4.
Oh, that's a 6.
That's a 6.
Looks like a 4.
That looks really weird. Sorry about that, guys. So that
Question.
is a 6.
It's okay, I do that too.
Okay, well, how did you get that though?
Okay, because all we have to do is plug in 6 from here. So basically what we've been doing, it's look at the problem. It says from the set 1, 3, and 6, which of the values can be substituted for x to make the equation true? So this is our equation. I'll circle it in green. Oops. Okay, let me get out of that. I'm circling it in green, and we're plugging in each number for x, the x over here, because it says substituted for x. So we substituted 1 and 3 before, but for this one over here, all I did was plug in the 6 because we did these two already. And when you plug that in, that's what we're doing. We're just plugging in 6. So does that make sense? Or
Right.
Yes.
You have to, so for you to like understand it better for like beginners, like algebra, basically, starters, I think it would be better to start the first thing that you see when you like did the question, when you already read the question, you should first make sure that all of them are numbers, so like plug in what you need to plug in and then you could do the work.
yeah, I agree. It's just make sure you're reading the question, of course, and then
Right.
make sure that you're plugging in each one. And that's why I would say do it on paper instead of doing it in your head, at least for now. When you guys get to 7th grade, 8th grade, you may be able to do it in your head. But since this is a very new concept and it's just starting out, it's definitely better to write it on paper just to avoid mistakes. And then remember, of course, Pemdas. It's requiring you to learn or requiring you to use everything you've learned in the past. Because you just told me about Pemdas. That's something you guys have learned. And you still have to use it even though we're in algebra now. So
Right.
that's why it's important. So I'm gonna clear this, move on to the next one. And okay, so this is our first experience like solving for variables. Number 1.
Whoa.
Okay, so I'm gonna show you guys how to do it. Have you guys ever solved for variables or not yet?
Don't remember what that word means.
Okay, so remember the variable is the letter. Variable is the letter. It's always gonna be the letter. So the variable is x in this case. So we're solving for x. Maybe you guys have heard it more as solve for x. But basically what you do is you move things around to figure out what x is equal to. So you use like opposite operations, move things around. That's how you balance out an equation. All right. So let's see. It says solve each of the equations and select the numbers that represent solutions to more than one of the 6 equations. Select all that apply. All right. I'm looking. Okay. So for these problems, as we did in the first problem, in the first page, what we were doing is we were kind of like checking to see if that one worked. And if it did work, we just put yes. If it didn't work, we put no. But for this one, and this is something that you guys should always know. Even though for these it would give us a letter, and we have to check it. There's a way of finding which number will give it to you always, because this one it's kind of like you're guessing and you're checking. Yeah, it's not even like it's giving you like it's telling you to guess and check. It's really what it's telling you to do, to plug it in and see if it works. But you could always solve it a different way and find the answer that always works. And I'll start with this one just to see if you guys are familiar with it. I'll show you guys how we get 3, how a is equal to 3, because you can find the answer just from looking at this. So it says 5a minus 1 is equal to 14. Now, in order to solve for a, this is always the trick when you're doing algebra. You need to make sure that you have a by itself and everything else over here. A needs to be by itself, because if you could look closely over here, a is by itself over here. A is equal to 3. There's nothing else there. So we have to move things over to the other side and just get rid of everything that's preventing A from being by itself. So the first thing is I'm gonna move over the 1 to the other side, right? And what you do to one side, you have to do to the other. So in order to get rid of this 1, you add 1 here and you add 1 there, and you have 15. And then now it's really close. Look, I said it needs to be just A by itself. All that's there is an A in the front. So I'm just gonna divide by 5 on both sides. And when you do that, you're left with A alone because these two cancel. And then you're left with 15 over 5. And 15 over 5, that's 15 divided by 5. You guys know that's 3. And notice how it's the same thing. So is this something that you guys have kind of seen before? It's completely brand new.
Completely
Anyone?
brand new.
Completely brand new?
Yeah.
All right. So does it kind of make sense? A little bit. A little bit. I promise that when you do a lot of them, you get more used to it. So it's very new. So that's why I wanted to save it for today. Just because it is a very new concept. All right. So it says solve each of the equations and select the numbers that represent solutions to more than one of the 6 equations. Select all that apply. So basically what we're gonna do, remember how in that other problem I just did, I got that A is equal to 3? Basically what we're gonna do, we're gonna find what each one is equal to for each of these. We're gonna go step by step by step. And then I'll tell you guys how to answer the question. Because the question is a little bit different. So let's see. 4x minus 3. I'll write that one out first. 4x minus 3 is equal to 17. And we want to solve for x. So remember, we want x by itself, and we want everything else on the other side. So what's the first thing you think we should do in order to start the solving process? Can anyone say it? Move over the 4? Well, a trick that I like to do when you have a number in front of it, it's always easier to get rid of your subtraction and multiplication before you do the multiplication or division. So it's always better to move the 3 over to the other side, just because when you divide by 4, move over the 4, you'd have to divide everything by 4. So that wouldn't work out. It would just be too complicated. So it's easier to just move over the 3 first, move over what's being added or subtracted just before you start dividing or multiplying. That's what I found.
1 second. What's above the 17 and to the right of plus 3? What is that?
Where? I'll read what's over here. It says 4x minus 3 is equal to 17. And then I'll rewrite this over here. But basically what we're doing, the black, I didn't know what that, I think that was someone writing on the screen. Yeah, I didn't know what that was. This is just me saying that whenever you're solving for a variable, you want the variable to just be by itself. And you can have 2 plus 3 plus whatever on this side. But all your numbers and other things have to be on the other side. But you just want the letter to be by itself. So that's what this is pretty much saying. I'll erase it.
So on the other side, like, are you saying, like, let's make it like a wall, like rooms. So you're saying that the wall is the equal sign? Is that
yes.
Like okay. That's
the wall is like the equal sign. And the X is just, it needs to be by itself in its own room pretty much.
Right.
Hopefully that kind of makes sense. So that's pretty much what we're doing. And it's just, it takes a lot of practice to understand it. But basically you just need to move things over and divide and subtract and whatever. It's going to get easy, I promise. But since it's the first time, it's probably a little weird. So let's see.
I'm not understanding it.
All right. So what are you understanding so far?
Like the concept of it.
The concept? So it kind of just goes back to like Pemdas, and it really does go back to Pemdas, because when you're doing this, you just need to do like the opposite in order to get your answer. That's really what you're doing. You're reversing the entire equation that you have there in order to figure out what x is. So remember how it says Pemdas, whatever. Now it's kind of like flipped. Now it's like you do this first, and then you do this, and then you do those. So hopefully that kind of makes sense. That's really what you're doing. So the first thing that I want to do is get rid of the -3, and over here. So what am I gonna do? It's algebra.
Backwards?
So algebra does go.
Backwards.
It kind of does go backwards. I will say that.
Okay.
It kind of does. So what are we gonna do to get rid of the 3 over here? We're gonna do it backwards. We're gonna do a +3 and a +3, because when you do -3 + 3, you get 0, and then this just becomes 4x. There's nothing else
But
there.
I don't get why there's 2 + 3s.
Oh, because what you do to one side of the equation, you always have to do to the other side. That is a very, very, very important rule about algebra. So I don't know if you guys have seen that before, but it's what will always remain true. So whenever you want to get rid of something over here in yellow, you have to do it to this side too, because that's the only way, like, your equation, the wall, will balance out. It's like, think of it like a scale. Like, I'm not really sure how to draw a scale, but you guys know like what it looks like, right? You have like things over here and things over there.
Yeah.
So that's really ugly, but like if you were to add like a green ball over here, what would you do? You'd have to add it over here in order for it to stay balanced. And that's basically what you're doing with this. You have to make sure everything stays balanced at all times. And that's the only way it's gonna work. So does that kind of make sense? The balance thing with the equal sign?
Yeah. But do you add whatever there is, like for example, for when you were putting the +3, is it gonna be 20 or is it gonna be 17 + 3?
It's gonna be 20.
Okay.
So yeah, that's a good question. So really you're just adding what you see here, and since -3 + 3 is 0, there's nothing there. I did that on purpose just because I want it to just be x. Remember, your goal is, it's like a puzzle. You're just trying to get x. And then when you add 17 to 3, you get 20. So then now the next step is to get rid of the 4. You divide by 4 over here because you're multiplying by 4. You have to do the opposite. You divide by 4. If you're multiplying by 4 in order to get rid of it, you divide by 4. If you're adding by 3 in order to get rid of it, you subtract by 3. So that's another very important concept of algebra. But you're always doing the opposite, and that's why it's kind of like an opposite math. But remember, what we do to one side, we always have to do the other side. So we have to divide by 4 too on that side in order for it to work. When you divide 4 over 4, you guys know that's 1x, but x can just be written as x. 1x is the same thing as x. And then you have 20 divided by 4. Can someone tell me what that is?
5.
5. So at least for this first one that we just did, the answer is 5. X is equal to 5. So look, I'm gonna erase these there.
1 second.
We have x is equal to 5. Yeah, what's your question?
You're doing that? You're doing the opposite to take it away, to like make it disappear?
Yeah, like that's kind of what. Oh yeah, finish what you were saying.
No. What were you saying?
Like it is kind of what you're doing. You're trying to make it disappear. You're trying to get rid of it, because in algebra the goal is to always, at least for now, the goal is to always get x by itself. The wall, like you said, you want x over here and all your numbers over there. It doesn't matter what's there. So that's what we're doing. We're getting rid of stuff. We're moving things over. We're canceling things just because we want x by itself.
So that's the solution to the problem.
Yes, that's the
x
solution.
to
Because now.
Oh. Okay.
So now.
Okay.
Let's see how it works. Because we have x equal to 5. So how do we know that's true? We can always plug it in again. for the x, minus 3 is equal to 17. 20 minus 3 is equal to 17. 20 minus 3 is 17. 17. Look how it works. And notice how we didn't have to just plug in random numbers to figure out the answer. We got the answer right away by using algebra. So that's kind of like what this process is about and what it's used for. So hopefully that kind of makes sense. I know that it's very weird now, but if it kind of makes sense, then you're also a really, really good start. Okay?
I wanna ask you a question, but I can't really say it. I don't know how to explain it. So can I write on the thing?
Yeah. So what I'll do right now is I'll erase like everything over here. We have to do 5 more of these problems. In this one problem alone. So yes, you can write it over here. And if you didn't understand number 1 or the 4x minus 3, we'll have 5 more to go. So there's still more to do.
What was the thing?
It was we're doing this one. We're doing 4x minus 3, and the answer was 5.
That you're trying to take away this by doing this.
Yes, exactly.
And if you do that, is the thing gonna be like this now?
Yes. Well, it could. It is like that. Like you're not wrong. Like when you have this, 4x is 17 plus 3. That is right. It's 100% right. But in order for us to simplify things, it's always just better to combine when you know it. So you just combine those two together, because it's really just 17
20.
plus 3, so 20. Yeah, like you said. And then once you do that, you can move on to the next step. But it's always good to just combine and simplify before you do the next part of the problem, which would be to divide by 4. But you want to combine these two first before you divide by 4, just because it's easier to do 17. It's easier to do 20 over 4 over 17 plus 3 over 4. So that's kind of where that comes from.
I get it. I get it. I get the thing.
All right. So hopefully other people are getting it too. And if not, we're almost at 11 a.m. So that's why I'm trying to like speed it up, just because I don't want to take too much of your time. But let's see what number 2. Let's see this one. 5x minus 2 is equal to 20. All right. So the first thing I would do, because notice how it's not in the exact format as what we're used to. I like to move it over and distribute, because that makes it a little bit easier for me to do what we did in the first problem. So if we have 5x minus 2 is equal to 20, we're not even solving yet. We're just making it prettier for us to solve. I'm just going to move the 5 over here. So that becomes 5x. And then I'm going to do it over here. So 5 times negative 2, which is negative 10. And then you have 20 over here. So now we can do what we're doing. And now we can like balance the scales like what we're doing. Balance the equal sign, make it equal on both sides. So can anyone tell me now what's the first thing they would do to make it balanced?
Add 10.
Okay, so add 10 over here.
Yeah.
And then that's it?
No, and then the other place. In the
Okay,
other.
good. So then now these two cancel out and you're left with 5x. But now it's 20 plus 10. You can write it like this, but it's easier to just combine them. So then you're left with 5x equal to 30. And then now what's the next thing we should do?
You should divide times 5.
Yes, divide by 5 on both sides. And when you do that, 30 divided by 5, that's 6. So that means we just got the answer to that one. It's 6. So this is kind of unclear, but I'm just gonna write it a little bit easier to see. The one that we got before was, the one we got before was 5, and the one we just got is 6. So that's how you would do it. It looks like It looks like, I think Isabella, she understands it, but does everyone else understand it? Please let me know. Even if it's a kind of, or if you don't understand it, you have to let me know, okay? Just because we want to make sure that you're getting it.
I understand the first one that we did, but this one's kind of confusing for me.
Okay, so which part did you get confused on?
So you already set, like, the first thing that you did was, like, set it up, and then 5 times minus 10 equals 20. I don't get that. And then under that, I don't understand that.
Okay, so how did I get 5x minus 10? Well, there's actually 2 ways to do this problem. But I chose to do it the easy way just because it's the other way to do it is like much more like further advanced. It would be like a little bit more confusing. But basically what I did, and you told me you understood how to do the first one, the 4x minus 3. I'm just moving it around. I distributed the 5 in the front because that's what it's saying. It's 5 times x minus 2. I distributed it just because I wanted it to look more like what we had seen before. Notice how the parentheses here kind of ruins the format, but if we move it over, the 5 times x, the 5 times negative 2, it's much easier to move things around. And like, remember, it's always about balancing the scale, making sure everything is the same on both sides. So, and that way it's just easier to move things around and cancel things out and do the math pretty much. But how did we get that? Well, it's 5 times x minus 2. You have to distribute it. You go 5 and then negative 2. So you do 5x, you got 5x over here, and then you have 5 times negative 2, which is negative 10. You're really just adding the 2 that are here, so you have 5x plus negative 10, but it just becomes 5x minus 10. I just didn't bother rewriting it, but it really is, you're adding those 2 that are there. But since it's a subtraction, it's just a minus. So does that kind of make sense? Or
Yeah,
not really?
yeah. It
Okay.
makes more sense now.
Okay, that's good. All right. So let me see. All right. So now I'm gonna try the next one. Okay, let's clear the screen. Oh, I think it's better if I just erase these. All right. So let's see. The next one, 31 minus x is equal to 29. So does anyone want to kind of start the problem for me? What should we do? Well, I will tell you this. It's okay to divide by negative numbers. You just have to remember the rules of negative numbers. So, I think what I would do is I would subtract 31 from both sides. You're left with negative x is equal to negative 2. And then you divide, and well, now it's negative x is equal to negative 2. Well, now all you'd have to do is divide by negative 1. And then you have 2. But there's another way to do it. So I'll draw it this way, and you can tell me which one you guys like more. So another thing you can do is just move things over to the other side. So I noticed that if I move this over to this side and this over to that side, I have to go plus x, minus 29, minus 29. And when you do that, you're left with an x on this side, and 31 minus 29 is 2 on this side. So it's the same answer. So which one did you guys kind of like more? Did you guys like this one, the first one more, or the second one? Or both are kind of weird?
Both are kind of weird. I don't get how to like put it to the like the other room, we could say. I don't know how to do that, but I do know how to, when it's already there, I do know how to like finish it off.
Okay, so really when you're putting it in the other room, you're just getting rid of it. In order to put it in the other room, you're getting rid of it on the other room. Like, in order to put it in this room, you have to get rid of it in this room. I don't know if that kind of makes sense.
Yeah.
So like, in order to move in order to get rid of it in the red room, you have to put it in the blue room. But so at least remember the first way. And then since this is a kind of a hard topic, I'm gonna stop here with this last one, and we'll finish up this page another day. Just because I really do want to spend like time on this, and I don't. After an hour, I know math can just get very, very annoying. I'm the same way. After an hour in math class, I kind of just want to go. But really, let's see what the original problem was. I'm gonna erase everything over here, just so that it's very clear what we're doing. All right. So let's see what it says. 31 minus x is equal to 29. Remember, we're solving for x, so you just want x by itself. So you were talking about how you wanted to move it over and how you didn't know how to move it to one room or the other. So if we want to get rid of it in this room, we have to subtract it over here because it's positive 31. We have to get rid of it in this room. So we do minus 31. And then we do a minus 31 over here, right? Does that make sense?
Yeah.
Okay, so we've done that. I'm gonna write the next step. The equal sign, of course, stays the same. These two cancel out, so you're left with negative x. And then what's 29 minus 31?
Isn't it plus?
No, this time it's minus, because you're always doing the opposite to get rid of it and move things over to the other room. So if you have 31 over here, in order to get rid of it, we do a minus 31. In the other problem, we had a negative 3. In order to get rid of it, we do plus 3. No, don't worry. So we subtract it. So everyone, what's 29 minus 31?
2.
2? Or is it
Negative 2?
Negative 2. Because 31 minus 29, the opposite would be 2. But now it's this. So this is kind of unclear. So what I'm gonna do is just erase this and rewrite it in a different color. All right. So what we're left with is negative x is equal to negative 2. So now all we have to do is divide and get rid of the only thing that's preventing us from making it like one of these is the negative in the front. So you guys know that this can just be negative 1x, right? It's the same thing. And when you divide by negative 1, you get your answer. And what's negative 2 divided by negative 1?
Negative 1.
Negative 1?
No.
Well, 2 divided by 1 is 2, right?
Negative
And
2.
It would be 2. It would be 2 because when you have a negative here, when you divide a negative by a negative, you get a positive.